Good morning. Happy Sunday, everyone. How are you? Let's get to it. So, first thing we're going to do is get my. I can't hear the music. So, I got to fix that. Just give me a sec. There we go. All right. And what after that? Actually, I check on my filters. Okay, we have that turned off today. Then we're back to a 5-second delay this morning because the Starlink weather predicted, yeah, small drops. So just a little bit based on past performance in the last 12 hours. We got some weather. So, first off, we're going to get started with a little bit of stream glitter. And I wanted to see why was Sneaky not working for us? We should have been able to catch this. See, we should be getting that sort of thing. Then I'm going to take the border box, remove the border. There we go. Now it should just be text. Okay, that's good. It's behind that though. Okay, let's take the particles and move them back a touch. Try it again. There we go, yeah. Okay. Now what we want is to adjust the particles a bit. I want it a little bit more in the center. Then if we adjust this to something smaller, does it work? I don't think it. Oh, it does. Okay. That'll be easier on the GPU. Okay. Process material, particles. It seems to be coming across okay. What I would prefer is to have a little bit more in the middle and a bit less on the outside. Whoa, that's kind of neat. A lifetime needs to be more. Oh, that's weird. So the radial acceleration, let's see what that does again in this case. Okay, so it's actually going out. So if we set it to -5, I think should be attracted towards the middle, right? Okay, now how do we get the textures? I want these not to just be this bluish green gray color. How do we get that fixed? Can we make them like red at least? No. Anything? How about we go to, what is it, not drawing? Draw passes. It's our shape. Material. Shader material. Empty. Oh, wrong one. We want a spatial material. Oh, there we go. Oh my goodness. Okay. Now you can see now we have some Z tearing. So let's go back out of this. It does seem like there's not enough variation. Okay. I want white. Okay. It's not quite the same, is it? Because this just changes the hue. Gradient texture? I've never used this. Let's see what this does. New gradient. Okay, colors. Ooh, we can choose colors. Got it. So the first one shall be red. Interesting. I don't know if that's actually helping any. Oh, it is. Look, we've got different shades of red. Okay. Oh, let's give him like 5. Okay, what else do we got? We got some yellow. Let's bump up some yellow in there. Okay, where's yellow? That's yellow. Where's red? Okay. I guess we just really need 3, don't we? R, G, and B. This one should have been blue. Okay, trash that one and that one. Is that going to give us everything? I don't. Can I turn on RTX? What's RTX? Oh, ray tracing. I don't know why we would turn on ray tracing for this. Why? What are you thinking? Oh yeah, I don't think there's a reason for Godot to support that. Can I rearrange these? Maybe not. Hmm. See, we're not getting a decent green between there. All right, let's have black all the way over there. Spread this out a bit. All right. That's kind of colorful. That's neat. That's neat. Take off the hue variation. Seems all right. Good morning, viable clan member. All right, let's try the scene out. Okay. I'm gonna have pre-process set up already. Where is it? There it is. I want to see them already there. I don't want them to kind of trickle in. There we go. Okay. Now let's see if we can get that on the other machine. All right. Now for the hard part. Export. Mac. Rust. Mitch builds. Should be fine there. I'm going to close the existing one. All right. Sourced Rust, Mitch builds, Mitch.dmg. Huh. That box is having an issue at the moment. Come on, box. You can do it. All right. And where did I copy it to? Oh. No wonder I couldn't find it last time. Now for the very tricky drag and drop into the applications folder. See if we get it. Drag and drop. Click the replace. Okay, we did it. We'll see how that works today. All right. You got me thinking about the ray tracing some more. Do game engines usually support ray tracing? I'd be surprised. Hey, good morning. We do. We're actually just about to step into that. We were doing our morning warm up of working on our stream glitter. So, how you doing? Patilans? If I said that wrong, let me know. All right. So at this point, We've got our fetch handler. Oh, and I found a new way, a different way, which was in the documentation. So I just found it in the documentation of getting properties off of JavaScript objects. So in this case, we've got a event object, right? The Cloudflare event object. And if we define an external seed block and we define a type, right? Then we can put methods on it. And we can say that this is a getter and it will match up the properties to the function names and create a getter for us. So instead of us having to create all of that, I just had to go through and define getters for all of these types that we cared for. Also, if we didn't want to fill in the getters for something, we just leave it as a type. Like, oh, yes, we know this returns this thing, but we don't have to provide properties for it. So I did provide quite a few for the first couple levels, the Cloudflare event. Actually, I'm going to crank my desk up. I'd prefer to be standing at the moment. Good morning, Xenocron. How you doing? Cranking the desk. There we go. So no, it's going well. It's going well. So I found a different way to get properties off of a JavaScript object. You define your remote type, right? Remote being something in the JavaScript world, some plain old JavaScript object. And then you can define getters against properties. So you say this thing exists on event, and this is the property type, and it'll return this for you. So it goes through and actually creates a lot of the methods for you. And in this case, there was type, which of course is a Rust reserve word. So we renamed it from type to kind. And that's just a string here. So it works out really well. All right. So I didn't do all of them. Headers, I think, is just a map of key value strings. One sec. Our little garden gnome. He's had a rough day. Can you see it? Um, we're gonna go back over here, and I did look for a way to what is it? Oh, to set up a handler, a router. But it turns out there aren't any really good standalone routers, and there's Routerify, but Routerify actually requires that you package with this MIO, and MIO doesn't have a WASM, doesn't have WASM support. So I looked at the core of Routerify, and it's kind of neat, right? Like most of these, Routerify lets you set up things. Let's see if we can find one. Oh, where is it? Where's a router? Router. Oh, here's router. So they have a router builder. And you say, I want to get this or get that. And you provide a function for that. So if it matches this, do that. If it matches this, do this. Okay. But behind the scenes, all this is doing is building up some regular expression. So given the permissive license on this, the MIT license, we have pilfered or lifted or whatever you want to call it, their actual regex code. Every time you're looking for the cam, it's in a different spot. Yes, got to keep you on your toes. Keep you on your toes, man. See? Oop, now I'm over there. Oop, now I'm over here. All right. So, actually, today should probably be on down here, but it's Monday, so maybe we'll leave myself upside down. Oh, all right, one more rotation. Transform 90. There we go. All right. Monday. Oh, it's Sunday. Today's Sunday. You're absolutely right. You are right. So if we look at this, they've got some interesting pieces here. Don't rob you of half your weekend. Like, surprise! It's Monday. No. Oh, that would be cruel. That would be cruel, Xenocron. I wouldn't do that on purpose. All right, but it does look like this would work. And looking at the tests, you can see that you generate a common regex string, and you can then use it to test against different things, right? This one's interesting with the star star. I wonder if people do that. Huh. Or would one suffice? All right. But we're going to be using this for our router, and we'll probably just build up a little router on top of that. Just something simple, something to be able to match paths, match verbs. Let's come back here. Okay. I've got to pour some tea early today. Going through the water quick. Almost there. Okay. So. Oh, thank you for the follow. Wait. Oh, I didn't start Mitch. It should have done little ta-da and all that. Oh, shame on me. We installed it, but we didn't start it. Okay. Should be going now. Let's double check that. Oh man, I love this song. Okay, there we go. Yep. It's going. On his OBS isn't gonna. Oh, hold on, because I didn't have OBS. Oh, that's funny because Mitch is transparent. It was sitting on top of OBS, so I clicked on OBS, but it didn't select OBS because it was clicking on Mitch. Go figure, right? All right. So we've got our handler here, and we can. Let's see. Maybe you'll graph Wrangler Dev. And please, if anybody has questions, stop and ask. Just interrupt, please. It's expected. Okay. There's our request. Here's what we logged out. This is the console log. These are all the extra little bits in here. Actually, look at that. LAX. We went to the Los Angeles Colo this time. Oh, that's crazy. That is just, that's amazing. All right. And now we're going to start to set up a router. The first thing that we're going to do is work on security. So probably want some way to be able to manage admin stuff. What do we want this to look like? Want some sort of router. Right, some sort of router. And then we would say, oh, that's returning the string. Let's leave that in there. Just toss a new router on there, or have like a router builder. And I wonder if we could create the router ahead of time. Because in this, it's not like we need to create our DB elements or like our database pool or anything like that, right? This is a worker. It just makes requests to the backend. That's something we could play around with later. But also, it's either going to start when the WASM is loaded. So unless we can get this to compile time, it's not going to make a difference. It'll happen either way, either outside of fetch handler or inside of fetch handler. All right. And we could say like .get foo, or let's say admin users. Something like so .build. All right. Builder. This shall return a router builder. Let's not see this in a different file. All right. It's private. You are correct. Good job, Rust. Okay. So we have our little router builder. We've got our router. Function get. And for this, we will take some sort of string. Path. And what do we want to call that? So if you're going to be matching a portion of a URL, I mean, that's the path, the query, the hash. What did the other crate call it? This song is a little, I don't know, like, let's skip this. Okay. Dependencies. How's the audio today? Is it too loud? Voice compared to music? Test create stocks. What the homepage? There we go. The repo. Source. See, they've got a router, etc. Seems good. Okay. Thank you. Oh, they've even got a builder. Yeah, we couldn't use this for reasons of hyper being in here. They have a list of a vector of routes, pre-middleware, post-middleware. Yeah, data. And then but what do they call that? They just call it a path as well? Path and then the handler? Okay. And I wonder, are we even going to need this to be send and sync? I don't think so. WASM is not multi-thread. It's like single-threaded. And we're not using workers. I don't even know if you can use workers on, or, web workers on Cloudflare or WASM workers. Let's see, they did an into string on this. We could do, that's interesting. Can do the asref. Can we just keep a reference to it and do this all at the end? Should we do it here? Yeah, let's go ahead and do the into string. P, and then the handler, H, we'll call that. And this needs to be on self. So we will consume self. Let's type that right, Halsey. We will return self. Oh, that's toasty. All right. So we take self, we get the path, we get the handler. Now, what do we want inside of the builder? some sort of hash map. Are we gonna have the pre, the post bits? I don't know if we need something that fancy. It might grow into that. So let's see. Because eventually we will build this and it will become a router. And the router will have this very, very similar internal structure here. But what do we want router to have? So let's work backwards from this. Let's see, here we're in this. We're pretending we've built this thing. So you build up the whole thing, then you say router dot, I don't know, match, run, process, handle. Whatever the event is going to be. And we will probably do this more of a event dot request. And we'll get the response from that. And we should probably return something a little bit more complicated than just string. Should probably return like a proper result, like a HTTP result. Maybe from the HTTP crate. A response. All right. So I don't mind making this a little specific to that type. However, we could make it generic, then maybe we could come up with a router like I wanted that isn't bound to any sort of, IO system. It's not dependent on, Tokyo or async anything. So let's kind of keep that in the back of our minds. Say like, okay, if we can extract router, we will. So that would be a nice sort of community contribution. Oh, we already have one. Function handle. We want to handle some sort of request. Or something that looks like a request. At this point, let's pull in that HTTP response crate. It's either that or we start defining out traits for responses, etc. I don't know. I don't really want to do that. But HTTP has responses in it. So we might use that. It also has request. And if we could go into this request from the other type, that would be nice. Why don't we just say it takes an HTTP request? Okay, let's do that. Cargo, add HTTP. Thank you. Handle the request, get a response. Toss it to do on that. HTTP request and response. Restart COC. Okay. And this seems like a decent sort of interface. You know, you have a router, have it handle a request, you get a response. What else could you ask for, right? Maybe, should this be a result? We might want this to be a result to a response or some sort of error. I don't know. Let's not do that yet, because request, we should be able to generate any kind of response from that. All right. Why is it bugging out? Okay, there we go. Oh, missing generic structs for that. Good, good, good. And body in this case. Oh, what is the body going to be from? Oh, I don't know. Let's pass it through. Is this also based on body for this type? I don't think these are the same types though. So that's a T, it's U. All right, we'll figure that out later. Now at this point, we will take the path, convert it into a string, create a regular expression out of it, because we've got this. All right. Parameters. So this is starting at, oh, they're using not greedy. Is that what this is? It's not greedy. So generate common regex string. What is this doing? We get the path. Parameter names. Interesting. Okay. So we get a vector of strings back out. Yeah, we're not really doing the prefix one. We'll probably always do the exact match. I'm going to leave that there for a bit though. And this could actually return an error. Interesting. It's not going to work very well for our builder. What sort of errors could that actually return? So it doesn't return an error from this code. Oh, when it creates a new regular expression. Ooh. Yeah, what should we do if that happens? If we don't get exactly the right thing. Just go like, oh. I don't really want to have to deal with that for the builder. And it would suck to have to be able to run this to know whether or not you got all your routes correct. But at least it would happen on startup. You would know right away. So we could just panic. Be like, no, this doesn't work. Thank you. Try again next time. I wonder what they're doing. Result. Scope data map. Huh. Yeah, they're wrapping this in other elements. What is this one? This is post middleware. New with boxed handler. Scope data map. So this is a pre-middleware, the beginning of it. So basically, you have whenever you have middleware, you have basically a stack of things that might happen, and you have what happens before the request, for the request, then after the request, and each one of those pieces is customizable. See, yeah, they're just returning the error here instead of returning this. So where does middleware pre get used? Expect. Handler, take, expect. No handler found in this. That so in this case, it's just returned. It's that or E. Where's E defined? So they're pushing this all the way through. Interesting. Pre with path. Yes. Result more. Hmm. And in their example, they unwrap it. All right, let's keep climbing the tree. Yeah, like that. It's the same. So they just bubble the error all the way up if it's a regular expression error, and then have the library consumer deal with it. Given that we are the library consumer, we've got some choices to make. And one of those is, how do we want to deal with this? Let's pretend that router here is its own crate. Let's create an error in router. And maybe we should move this regex generator into router. Let's do that real quick. Okay. Can I find H in the scope? Oh, we have to define it here. Okay. Good. We need to move this. I'm going to commit this to here. Ooh, Bumpalo. Who's using Bumpalo? That's neat. Organizing router. That's fine. Move source. Hold on. Let's go into source. Let's rearrange this. Make to a router. Move router.rs into router as mod.rs. Move regex generator into router. Just start that again. All right, now what do we do with all of the errors that we might get here? It would suck to have a builder with a result here. And I don't think the other crate is doing that. So in their case, oh, this is HTTP. Are they unwrapping it at the very end so they hold on to the errors? Oh, yeah. Okay. All right. We can do that too. I guess that makes sense. Yeah, kind of. You lose context a little bit. Yeah. Oh, this is gonna be fun. It'll be a challenge. Okay, so we take this, toss the path in there. And what do we get back? We get back great result, a regular expression, and a vector of strings. So we're probably going to need something like a route. We could toss this stuff into the route. It's either that or an error. And our router builder will just have a vector of these. Just keep adding them to it. What if we just did that? Like, good morning. How you doing? I'm parsing this. Give me a moment. It's going pretty well. It's going pretty well. So we'll convert this either into a route or to something else. Actually, so let's do that. Results will be equal to this dot. It's a result at this point, so we will map the good part, which would be a regular expression and vars, variables, into a function where we create a new result, or new route. Otherwise, we'll map error. Do we have to map error in this case? I don't think we do. It'll just be that boxed element. Oh, path dot as stir. No, that should be as ref, huh? Regular expression, and then a vector of, was it strings? All right, we'll just use default on that. It should work. Routes, plural, not router. Expected it to be static. What we found, oh, interesting. It's send and sync, but not static. Really? And this result type says it's static. And technically this is, this should probably be in that other mod here. That should be over here. Just toss that up there somewhere. Okay. Now let's toss a build on there. A function build. Consume self. And returns a router. Or, actually this is a result router. Similar to HTTP and Go. I'm actually not very familiar with HTTP and Go. However, there are many different frameworks for Rust. Now, what I'm trying to do is a little specialized. So I wouldn't expect people trying to make a website to jump into what I'm doing. I'm trying to use Cloudflare's workers to kind of build up a serverless website builder. Okay. I think WordPress, but no backend. And are we web yet? I think is what you're looking for. Oh, great. Frameworks. So there are a number of frameworks that are great, right? I've heard good things about Rocket. I've used Actix Web, well, forever ago. Warp, I use. Tide, I want to get a little bit more into Tide. I haven't used it as much as I want. Thruster, I've never heard of. I've seen nickel and iron. And so, yeah, take a look at these. These are just a great place to start. So past this, if you go back, how do you get back up one level? Can you? I want to go not to topics framework, but up. So yeah, if you go back up to the top, you'll also see DB stuff, like if you wanted to connect to a backend, all sorts of stuff in here. Yeah. Email, templating, etc., etc. Oh, you're very welcome. Very welcome. And yeah, let us know if you have more questions. Because yes, I am not able to use those libraries because of where I want to run this. I'm trying to run this on a Cloudflare worker, and a Cloudflare worker is doing all of the I/O for you, right? So I don't need, let's say, a Rocket, right? I just need the piece of Rocket that does the handler, right? It figures out which route to run, and past that, actually, it just dawned on me that Cloudflare could do that for me, couldn't it? So are we doing this backwards? Hold on. Where is... No, that's not it. Getting rid of this. Gonna log into my dashboard again. This one. Workers. Custom zones, matching behaviors. See, those aren't quite the same thing. To enable workers to run on custom domains. Not so that you can run a different script for a different element. Because right now we're kind of building something that's monolithic, but we could break that down if they support it. Do the matching here outside of our code. Yeah. No, that's not going to do it for us. Okay. We'll still have to match it inside. Oh, they've got all sorts of interesting things here. And considering that you can run WASM scripts, like WASM, on their edge network, just makes things incredibly scalable. Kind of like, Lambdas at Amazon. Or what do they call them on Google Cloud? Are they just functions? Cloud functions? Okay, let's put this one over there. We'll need that later. Close that. Okay. Unresolved module. Yes, you're not there anymore. That's fine. Expected 2 arguments. Found 1. Oh, yes, we have to give this a handler. What would we want to do with this? So, we would get something here. I'm just going to call it like E for event or something. We get the event, and we have to return some sort of results, response, etc. I sense a new presence among us. Oh, look at that. It worked. We were working on that earlier. And welcome, Caro. Thank you for the follow. That thing was so, I don't know, big. It's not quite how I want it, but we only work on it little pieces at a time. All right, so admin users, we're going to return something, of course. Now, event here. Can't find, yeah, of course you can't find event in the scope. That's fine. That's fine. So let's just use CF event there. Get rid of this one. Yeah, that's a little, that's going to change. Lots to do on there. Okay, yes, that's giving us errors for whatever reason that don't actually exist. This one, Oh, because we didn't unwrap this. All right. Now, given that we're going for a very minimalistic sort of router here, um, our routes here are going to look very similar to this here. Almost. Come on, Vim. There you go. It's not going to be results, though. Those will have been unwrapped by this point. I'm going to move the routes up a little bit. So we have route, we have router, we have router builder. Okay, 3 little elements here. Then what is the handler going to do? It's going to take in whatever the request is. It's going to pass it to a certain element and say, deal with this. Good luck. And go on from there. So let's see. What we should only have to go through through the routes one at a time until we find the one that matches. Once we have one that matches, we don't process any more after that. So self dot routes. I want to see which one matches the request. What does the request have on it that we could match against? So let's use our built-in. Oh, let's see. Does this actually build yet? No. What else do we have? It's a super result. Yes, yes, yes. I know these are wrong. Just leave me alone. Router.handle, event.request. This needs to be some sort of. Yeah, we need to convert that CF request into an HTTP request. Impl. Oh, these are both 2 foreign types? Can we even do this? Impl. From. Yeah, from request. For HTTP request. We need a type on there. What? From has an incompatible type for trait. Expected function pointer. Function found T. Oh, here. Yeah, why did it do that? Do I have something going on with my... Let's see, there's implement and missing members. Let's give that a save. Oh, now we have two of them. Where's the top one coming from? Because that one's wrong. It should just be this one. Same. Okay, pretending that we have something like that implemented. We'd call inot or into on that. Oh, it cannot resolve T. Yes. Because we don't know what T is here. Just gonna pretend that it's like so. The HTTP request. There we go. What else? Oh yes, and we have to know the type of response as well. That's not used, and that's fine. Does it at least build? Okay. Close enough. Now we're going to do a cargo doc. Open. One of the best things about Rust, you can have local documentation. Don't have to rely on the search engines for all your answers. And it works really well. It works really well. All right. You can see all the crates that we have as dependencies. Oh, and Bumpalo. That's a fun one. Bump allocator. Okay. Come back here. Great. So, coming back from lib, we have to be able to convert these. So maybe we should fill in this first. A little conversion. Let's see, that's going to be in CF. How do we make a request? I want to make a request object. Is there a request builder? I think I saw it in that list. So there's this builder here, or you can just set a number of things. So you can set the body here. Create a builder. Okay. We could at least give it the URI. Give it a body. That's what we do at the end. Okay. That means that we have to know what kind of body that we're actually getting from Cloudflare. And in these cases, we don't know. I think body's always been empty so far, at least for all the GET requests, and that makes perfect sense. Okay. So we have a builder. Method is going to be r dot method, isn't it? I think we define that up here. Yeah, method. URL is r.url. Body is empty body. R is request. Request method should be this here. Should return a string. That's strange. Is that just COC or Rust Analyzer? No? Okay. It's not implemented for method. Oh, I thought it was on this side, not that side. The following implementations were found. Okay. You know, I'm seeing the functions right here. Why does the compiler not see the functions? Or why don't I see what the compiler is saying? Let's go back a little bit. Okay, request, builder. Isn't this what we're doing? Request builder dot method dot URL. Okay, let's deal with the first instance here. Does that work? It does. Let's look at method. What does method say? Or method T. Oh, method try from T. And what is... Isn't that implemented for string? So do we have to convert that to method first? Aster. Partial equal, yada yada, debug. Try from. All right. Gotta help my wife real quick. Be back in a minute. All right. Hey, how's it going? Birkin. Good morning. Simple fromster for method. Oh, I didn't realize that there was a proper fromster. Yeah, that's unstable. Ooh, okay. Yeah, so we need to take this Arta method into a local. And this should be a string. Rick Ashley. Rick. Huh. Is this more of a try from? How do we convert that into the method? What linter are we using? We're using COC with Rust Analyzer. All right, but if we just have the type there, okay, yeah. Yeah, COC. Conqueror of completion. That should work. Yes. All right. Now, how do we convert our string into that type? Is from bytes. The linter, yeah, linter's clippy. We don't really have a thing for clippy, but it's just a cargo clippy. It's like, you know, kind of part of the compiler plus plus. Just enables a bunch more rules. Uses a lot of the same pipeline as the compiler. Oh, I see. They're matching on the length first. Oh, interesting. Clever, clever. All right. Well, I think ours is going to be a get. It should be in here. And source is going to be lowercase. Who calls from bytes? Anybody else in here? Try from. Okay. Why didn't that work for us? From bytes? Wait, does this just want... What's a slice? Good. Okay. So this is going to become a try from. And yeah, what is the error type? I don't know. Is it going to fail for any other reason? Because if it is, we'll have to deal with that. Should return as result or an option. Okay. All right, now what is the error we have here? From bytes returns what kind of error? Invalid method. Where do you get that? Oh, you like this song? Well, you should thumbs up that song then. Hit the little button down over there, or spend your channel points wherever that button is. I just want to test the function. All right, then we have URL. There is an associated function with the same name. Oh. Really? Oh man, I love this song. Hey, look at that. I come over here and we didn't automate this part, but done. There you go. Oh, it's called URI, not URL. Yeah, that little gap there means a whole bunch. Wherever this is, URI. Oh, the T versus unit. Okay. Body here. Yeah, we don't know what type that is. This here. Because only if we have body do we create it. nothing else builds this, does it? They have other good songs. Here, let's play Etherwood. So part of the issue here is that I don't know what the type is for the Cloudflare body. In the Cloudflare body here, I made up the return type. It's an option to a string. But I don't know if string is correct. You can see, is the body used? And it returns a true or false for body used. But, what does body return if something is used? So maybe we could do like a post to this URL. Let's see. Network. What's a good tool for creating requests? What's a good request builder tool? It's not like Postico, but it's a Postgres tool. I know I've seen some really neat ones lately. Hopscotch? No. I don't want to use Rails. I know I've seen this with Rails developers. Yeah, no. I don't know, interface? Something. Not RSpec. We don't want RSpec. Huh. Essentially, all I want to be able to do is say, this is a request. I create a new request. Could probably use like Charles or something else for that. All right, how about we come back to lib. Instead of this, let's just put in like a little form here. Form. Put name equals Bob. I don't remember. Where does a form post to by default? That doesn't make sense to have that. Okay, good. Event or request dot into because our CF try from. It looks like it's doing the right thing. What? Cargo check. I want to see the bigger error. Oh, it's try from. Try into. Good. We'll just unwrap that for a moment. Want to get it compiling. Okay. Regular dev. Listening. Good. Oh, we threw an error. Internal server error. Unreachable. Oh. Oh. What? Do we have an unreachable block? No. Okay. I'm guessing it's in one of those. If it's because of this, I'm going to be surprised. Oh, maybe also the router? Because we didn't finish all of that. Okay, what we want to look at is what is the response, the request body if we do a post. Oh, that's not what I wanted. Response result. What? All right, our response type here needs to have a MIME type. There it is. Runtime APIs. Request. Actually, this is going to be a response. Maybe a request would show us. Let's say request. Part of the fetch API. Yes, can be one of any of those. It all looks like a string to me. We just have to parse it. Readable stream. What is a readable stream? All right. And why can't we include HTML in our response? Oh, there's readable stream. Okay. We'll get to that in a minute, but HTML writer? What is this? It can be thought of like a jQuery-like experience directly inside of your worker's application, leaning on a powerful JavaScript API to parse and transform HTML. HTML rewriter allows developers to build deeply functional applications. Well, that's nice and fancy and everything, but how do we just return? We want to return it. Learning, examples, get started. Oh, here we go. Oh, we have to provide the content type. Okay, and the headers, that works. Status. I sense a new presence among us. Anyway, thank you for the follow. Good morning. Uh-oh. Did it stick with the glitter's still there, isn't it? Uh-oh. I gotta restart Mitch. Oh, that's funny. All right, it's back. We'll have to deal with that tomorrow morning. Oh, there we go. I am Bob. Okay. Hey, Bob. What's going on? Okay. URL encoded. Great. And what if we wanted this to have Action. Foobar. Body was null. Can't remember the last time I actually built a form like this. Method get, action blah. It's been a long time. Usually using like XML HTTP request. Let's come back into lib. Equals multi-part form data. Oh, it crashed. All right, so that, if we look at the network there, that should have been, what? Oh, it's still, we want it to be a post. Method, action, target. Okay. Anything else? This is a test. Okay, now we have a post. Good. Good morning. Morning, Juan. And let me know if I'm saying that wrong. Wayne. Oh, Wayne. I get it now. Oh, that's a W. That's clever. Very nice. Okay. So our last request. Body locked false. Body used false. It was a post. Oh, this is strange. It's locked and false. Morning, Modprog. And thank you for the raid. Welcome, raiders. How's your stream? All right, looks like body is something special here. And we saw a little bit of that over here. The runtime API's streams. It's a readable stream. And we saw locked. If it's locked to a reader, interesting. Okay, so this needs to be of type readable stream. Just call it a readable stream. We'll define it down here. So what was I doing? I was saying, oh yeah. Web type, readable stream. And what can we do with a readable stream? Pipe 2? You wasted 2 hours on trying to find a way to set the notification text on Twitch? What? Oh, programmatically? Ah, well, have a nice jog. And thank you again for the raid. Good morning. All right, so what can we do here? We can pipe it to a destination, but if we want to read the body, oh, there's no API for that. Ooh, I see. Even in modules, yeah, this doesn't do it. Channels, modify channel info. Yeah, title, language, and game ID. That's not going to be it. Huh. Gotcha. I see, because this could end up being a slow read. Bring your own buffer read. Okay. Hmm. So you give it an array buffer view. Looks like we have to await this. Readable stream. Fancy. Okay. Yeah, I was thinking BYOB too. Bring your own beer. Or are those Node.js streams? I'm guessing this is run inside of something that it resembles Node.js, or at least V8, right? And because this is a Cloudflare worker, they're running a modified V8. Best guess. And I'm not sure. I think they do it for security and performance, because Cloudflare workers, um, the WASM is run inside of a V8 instance. Excuse me. Yeah, we don't want to transform it. We just want a readable stream. Probably do this. Using streams. It looks like it's referencing a spec here. Why wouldn't they run it in a Rust runtime? WASM runtimes for us, like the two big ones. There's WASM. WASM time. That's one of them. What's the other one? Is it just called WASM? No. WASMer. Yes. Oh man, I love this song. Birkin, thank you for the follow. Oh wait, for the thumbs up. Oh, we'll do that. Sorry, I saw that out of the corner of my eye. There we go. Startup speed, execution speed. But you're right, they could absolutely be running one of these. I mean, why not? In a megabyte? Sure. Oh, this is the most famous song of Etherwood. I've liked their stuff so far. Wow. Looks cool. Oh, on, you're absolutely right. I hadn't even considered this. It does mean they would have spent a bit of time implementing a number of APIs. Because if we come back to Cloudflare, platform, languages, JavaScript, TypeScript, huh, WASM, COBOL, I like that. Oh, you're planning to use Dino as a WASM execution engine. That's cool. Web standards. Timers. Fetch global. Okay. So yeah, they didn't implement anything, everything. Hmm. I wonder what they did this in. What did they build that in? That'd be fun to play with this. Anyhow, back to where we were. So we end up getting a stream, right? And it's the streams RFC or spec. It's a spec, isn't it? Pipe chains and back pressure. Wow. All right. We might come back to that later. I'm guessing for most of the stuff we are going to be doing, it's going to be just taking that into some sort of blob and storing it. All right, now coming back to Kitty. Yeah, now we've got a readable stream there. We could say this is readable stream, but that doesn't really work that well because the response, you would have to be a writable stream. Oh, expected value, yes. Needs to be an instance of a writable stream. And our responses, can the body can be a buffer source, form data readable stream. Oh, we can create a readable stream as part of the response. That's interesting. Up in. All right. What else could we say that we returned if it's not that type? What's a USV string? What? Oh, Unicode scalar values. Hmm. Okay. Oops. Go back. We closed it. And a buffer source. Array buffer. Typed array. Okay. Readable stream cannot be created directly using the readable stream constructor. Okay. Then how would we create one? Would we use a writable stream and then convert that? Worker scripts don't need to prepare an entire response body before delivering it to the event.respondWith. You can use transform stream to stream a response body after sending the front matter, the HTTP status line and headers. This allows you to minimize visitor's time to first byte and the buffering done in the worker's script. Minimizing the buffering is especially important for processing or transforming response bodies larger than the worker script's memory limit. For these cases, streaming is the only implementation strategy. The two primitives developers use to perform active streaming are transform stream and the readable stream pipe2 method. New response. What is readable in this case? This is interesting. So basically we could handle it. We need to get async set up in here. We're going to look up Rust, WASM, and async. Oh, that's right. There was a WASM bindgen async setup. Many APIs on the web work with a promise, such as the async function. Naturally, you'll probably want to interoperate. First thing you might encounter is the need. I sense a new presence among us. For working with a promise. Hey, thank you for the follow, Ars. How you doing? For this, you want to use JS syspromise. Once you've got one of those values, you can convert that value to WASM bindgen futures JS future. This type implements the standard futures trait, which allows naturally using it in an async function. For example, that's what Dino does. I see. This corresponds to then and catch in JS, where a successful promise becomes OK and an erroneous promise becomes error. You can also import JS async functions directly with an extern C block. For now, the return type must be JS value or no return at all. Interesting. Okay. So we can't do, how do we? Well, that's kind of a bummer, because what if we needed to return or get something from an async value, like a stream reader or something like that? When using an async function in Rust and exporting it to JS, there are some restrictions on the return types. Ooh. The return value of an exported Rust function will eventually become result JS value, where OK return turns into a successfully resolved promise, and error is equivalent to throwing an exception. The WASM engine features crate bridges the gap between JavaScript promises and Rust features. Its JS feature type provides conversion from JavaScript promise into a Rust feature, and its feature to promise function converts a Rust feature into a JavaScript promise and schedules it to be driven to completion. All right. Let's look at the API here. It's the whole driver of the implementation. This is where Ryan Dahl says they can do it faster. I have not heard of Ryan Dahl. Who's Ryan Dahl? Oh, interesting. Oh, the Dino guy. Yeah. Okay. That's fine. Getcha. I getcha. I want to know if JS value is any value that I have in here. Are these JS values? I expect that they're JS values, but I'm not certain. All right. Now, what if we wanted this to be async? What do we do? Oh, what'd you do with a drunken sailor? What did you do? Because it would be nice to be able to have something like this, have something asynchronous that we can then respond with. Where's response? Oh, here's response. Fetch from the origin server. This is the response we're going to send back. Here's the response. Body to pipe to writable. Transform stream. I see, and this could be whatever you want to transform here. Oh, please, yeah, go ahead and link it. All right. So given this, we could figure out what is going to be generating the body and set that up in the request handler. Right? So really we just want some transformer. No, not a transformer. We want more of a generator, right? We're going to be doing the whole thing. I mean, we might collect a couple pieces. I like this one. This one's fun. I'm going to thumbs up that one. What's this one called? Forest fires? This doesn't seem like this is someone else. I thought we were actually going to play the set of tracks. Oh well. All right, so let's pull in WASM BindGen futures. Okay. Future to promise, spawn local. All right, so we already have WASM pack. We want to learn. I guess the guide is kind of it, right? Well, there's not a lot in here. I don't think I've heard him speak. I'm still not hearing him speak. Ooh, an ad. Let's skip that ad. Hold on a sec. Why is this not coming through? That's Firefox. That's wired up. I'm going to delete Firefox and add it again. Maybe it's a different Firefox? There we go. Oh, did you hear how he called what he called it? He called it Deno, not Dino. Let's bump up the volume on that. It's embeddable. Wow. I'm going to leave that up over there. We'll come back to it. Well, maybe. Might just. Is that? That's not coming through anymore. I've messed up my audio system. Oh, here we go. There it is. That does sound a little bit louder than it was. Oh, you know what? I think I had it at 50%. There. That's it. Now, I was expecting a little bit more from this wasm bind gen features, but it is very simplistic. There's just 3 interfaces to the crate: JS feature, feature promise, and spawn local. Oh, where output is nothing. Oh, that's interesting. So actually I'm curious about whether or not, let's go back to the code. This could be async, pub async function. Could we actually have that? Because then we would want to come up in here into workers and, what is it? Await this? Or no, we don't do that, but we return something. We return the result and the response type. So this would not, oh, where to go? Not be async, but it might return something that's async. Yes, because we're going to be building up a response type here. Properties, body used. So that'll be a future, right, in the form of some sort of stream object. But everything else needs to be set already. So let's change this so that we're returning a response object. CF. We've got request. Response. Now we can define getters and setters for the parameters here. Oh, well, for the properties particularly. All of these are optional. Ooh. What are headers? Headers object. All right. Come back a little bit. Oops, too far. Response. Let's define these here. WebSocket. Oh, interesting. I mean, how long could you actually use WebSocket inside of a worker script? Your worker scripts are supposed to be like super short. Like, that's going to be way too long, right? Wow. I actually want to go to the, I guess they're cloudflare.com. Products. Solutions. Pricing. There we go. Overview. I don't know. Just give me one. Let's say Pro. $20 a month. Fine. Pro plan. Learn more about workers. Yes. Is Dark Reader on? Yeah. Okay, there we go. Oh, my side is sore. Yeah, what about WebSockets? What are the constraints? How long can this actually run? Okay, bundled. Up to 50 milliseconds of CPU time per request. That's not start to end, is it? That's not start to end. That really is interesting. Because that means you could basically have like 30 minutes that you're connected, as long as you only use 50 milliseconds. All right. At least that's how I read it. If it's not that, then and it's just like wall clock. But that's not wall clock time. That's CPU time. Okay, now WebSockets makes a little bit more sense. Just a little bit. A little tiny bit. All right. Let's build out response. Where was it? Here it is. Can we copy this? Is this going to be a horrible? Only partially horrible. We're not going to do WebSocket for this. All right, body used. Now, how do we have to do this again? Oh, yeah, that's right. Select this club function, that, this. Royal Blue Stag, good morning. And this is going to be a response. But what about it being a setter? How do we do a setter for Wazenbindgen? I think there's a little bit more that goes into it. Yeah, you pass in the value as the second element. Okay. And then whatever the type is. Okay, we'll have to come through, clean that up. So the body here. Wait, what? Oh, setters must start with set underscore? Touche. Makes sense. Because the getters don't start with set. And it's a very rust pattern. Very rusty pattern. Good evening. You must be overseas, huh? At least from where I am. All right, this is going to be bool. Although, does that make sense for this property? Or was it here? I guess, yeah, we would want to set that, saying, okay, yes, we included it or not. Encode body. Okay. That's going to be a string for encode body. Set headers. It's going to be a headers object, which we don't have defined yet. Subtype. Oh, we do. We have headers. We don't have the functions on it. Okay, it's just a boolean. A boolean. Redirected. Another bool. Status, an int. We're going to go I32 there. Yeah, that's a status code. They should always be positive. Status text is a string. And then the URL is also a string. All right, now set body. This one is a readable stream. And that can't be created directly. An instance of readable stream BYO BReader is functionally identical to readable stream default reader with the exception of the read method. Returns a promise with the next available chunk of data read into a passed-in buffer. What do they mean? Returns a promise with the next available chunk of data read into a passed-in buffer. Written into a passed-in buffer? Even though you allocate 1 megabyte buffer, the kernel is perfectly within its rights to fulfill this read with a single byte, whether or not an end of file immediately follows. Okay. That's interesting. Okay. And are these things all basically the same type? Because I can't provide all three of them. It kind of sucks that JavaScript can do this and Rust can't. Okay, we'll just call this one of these. So that way we have our type defined, all of its functions defined. And we can rethink this. In this case, the request This is going to be a readable stream. Actually, I think it's going to be a readable stream BYOB reader. Because if we're trying to read this, we can get the reader. Default reader. A promise that returns the next available chunk of data being passed through the reader queue. That seems fine. Oh, this is for... Yeah, that's fine. Oh, but we need the type. We need, from the request object. Oh, in this case, we actually have to create the builder based on that. So maybe a builder isn't, or maybe the HTTP request isn't the right type for this. So I don't know if that can actually, I mean, the body could be whatever we wanted. This is r.body. Okay. Well, that's nice. I'm glad they did that. That's a nice API. Okay. That's good. Let's clean up some of these. We'll need those here in a moment. So what we should be returning here is going to be the response object. We'll return a CF response. And then our worker won't have to do that. We will just return the response. Super thin on the JavaScript side. Okay. What is this? This is our, I don't know, our entry point. Okay. Fetch handler, here we go. Just log out the URL. Back into Cloudflare. And pull from CF response for HTTP response. So we use a builder. Oh, no, we already have a response. We need to fill in the Cloudflare bits for the Cloudflare response. Oh, what's a constructor? We don't have a constructor defined. Okay, where is the constructor? All right, pretty straightforward then. Function new. I did this backwards. This needs to be from HTTP response for CF response. There we go. Yes, because this one needs a type. Yeah, we're going to have different body types based on this. So if this is unit, oh, this would be false. We should rename some of these. JS name. Okay. That's a little better. All right. Now, in the general case, we'll have to do this a couple times. One for HTTP response of a certain type. I think we've really got two types. One being unit, in that there's nothing responded. The other being that there is this readable stream BOIOB reader. So we're going to have both of those. We'll add the other one second. Let's see if we can set all of these. Okay. Uh-oh. Did I got rid of the bottom of that whole thing. There we go. Already did that one. Auto, I think I read that was the default. Headers, that one's going to be a little tricky. I'm not going to have that yet. Set OK. Oh, whether or not it was successful. So if the status range is in the 200s. Okay, so const is OK is equal to r dot status. That's a status code, and this status code okay. Status code from bytes as U16. So we can convert it to that in order to figure out if that's it. As stir. Ah, here is success. Oh, perfect. Is redirected. How do we know if this is redirected? I guess that'd be in the headers, wouldn't it? Oh, status code is redirection. Perfect. Is redirection. All right, set status. And this is U32. Has U16. Okay. Set status text. You know, we should just extract this out to local. There we go. As stir. I don't know. What does this set status text actually mean here? I see. So they want the literal string. Um, not canonical reason. If there is one. Interesting. If let some reason. And the URL. Wait, why do we set the URL on a response? For the redirection? Oh, I see. The value is the final URL obtained after any redirects. I'm not seeing any URLs here. So we're going to skip this one. All right, so we have the body, auto encode, yes, yes, yes. Reason, owned. Okay, that's a close kind of first approximation here. Body, headers, URL. Got some important pieces in there, but they're not ready yet. I think in this case, body just won't be set. And in the other case, where the response is a different type, like so, then, yeah, I know. Then we do that instead. And we set this to true. That should be with the body. Expected value. Oh, yeah, I know. It should be r dot body. There. Interesting. Into body. Or, ooh, into parts. That's interesting too. It's parts. Yeah, then we have header status version. Oh, let's do it that way. Do we even need version? No. Extensions? No. All right. But if we do into parts, then we get the body separated out. Okay. Into parts. That's right. This needs to be tuple with parts and body. And we just set body here. There. Now we avoid a clone. And the parts can be broken down even further. We're not going to take extension or version, just status and headers. Now we don't have to pull that out of there. And now we just need the conversion for the headers. That's so much nicer. I like this better. Let's do this up here. I'm going to drop body too. Okay. Get rid of that, get rid of that. Now we just have this piece here. And what about the headers? It's like a hash map. Let's make a little conversion for those as well. Probably next. We'll do that next. Let's open the documentation for Rust itself. Rust up, doc. It returns a type name. Type ID. Interesting. So we could look at the type ID of something. So if instead we did T here and here, and then depending, we'd set the body to one thing or another. Of T. Missing match arm. Okay. So if this is the same as unit, I sense a new presence among us. How do we pronounce this? Gigimon? Good morning. And thank you for the follow. Thank you. Body's going to be equal to, let's see, if we return unit. Otherwise, what do we have in here? If not, then it will be r.body, the request body. It should be a readable stream. Oh, yes, yes. Is that not going to work? Oh, they have incompatible types. Yes, of course they do. Which will change the return type here. And which means we can't do it this way. Sitting on that edge between JavaScript and Rust, like we keep going between the two. It's like, oh, I could do this in JavaScript. Oh, I can't do that in Rust. It gets me. Because this would be an HTTP request builder. Okay, yeah, let's undo. Can't do it that way. Just gonna deal with the deduplication or the duplication. And in this case, it's for unit. This is for readable stream. All right. Have I explored Dino core crate? No, I haven't. I've not touched Dino. Let's take a look. Oh, which version of Tokyo are they using? Anyhow, futures. Oh, Tokyo here. Futures, interesting. So why would I want to use this over, let's say, going back to our earlier discussion, let's say WASM time or WASMer? Well, I guess if I wanted to run JavaScript, that's a big one. TypeScript, JavaScript. So Dino cores the embeddable pieces, I take it? Actually, a little bit of dust on my monitor. Have you used it for anything? I sense a new presence among us. Shaybix, thank you for the follow. And good morning. Happy Sunday. Oh, I see. It uses V8 native functions. Makes sense. There we go. It's getting a little wobbly. Oh, I see. Just a moment. Yeah, oh, that's so much better. Okay. Feels much better now. You're using Dino for calling WASM. So then why not WASMer or one of the others? Why Dino? Type annotations needed. Cannot figure this out. Okay. Why not? That request is fine. The handle should be... Oh, it doesn't know the U from that. Well, in this case, if that's there... Interesting. Oh, confetti's blocking the view. Ah! We got a bug. Oh, we got a bug. Okay. That happened before, too. We'll probably look into fixing that tomorrow morning. We do a little pre-game show with working on our stream glitter. Okay. There we go. It should be running now. Yeah, it's running again. Now, router handle. This returns something of you. I'm going to say the returned body type is empty here. Expected one argument, found two. Turbofish. Got a turbofish right. And thank you, GGMon, for pointing that out. I don't always see that. So if you ever see anything wrong, let me know. Okay, looks like that works. So we get a builder. Map this to that. Get filled in, kind of, but not really. Build. We should finish build. And in this case, we can collect into a different type and unwrap. So let routes is going to be equal to self.routes.iter.collect. And we're going to throw on that, or pipe that out. Use a try operator. It's not throw. What's the right term for that? Bubble? We're going to bubble the error out. We're going to flip the result here. Can we just flip that? Does it know how? Now router, what does router have? Just a vector of routes, fine. Oh, it needs to be an OK. I knew it. Okay. This over here, we have to have the correct type. Result vec route. Oh, please. And if you have questions about Rust, anything of this, just please interrupt. Let's see, 1, 2. Oh, we need one more right angle bracket. Collect. Yes. So it doesn't know how to do that. Error send sync static. Error send sync. Oh, it's not static. Why aren't those the same types? They should be the same type. See a little static there? Actually, Rust has fantastic error messages. Hey, Miguel Merca, how you doing? Cannot be built from iterator, item, result, route. Yeah, we want a vector of routes. It should be able to collect into that. The trait from iterator here is not implemented for result. Oh, ah, intuitor. There we go. Okay, that works there. So now we have the build. The build should bubble out those errors. We can expect if it's wrong. What else? Build works, hopefully. Handler we're not doing anything with. We should be tossing this into something. Because handle, our little router is not doing anything. Now, let's look at iterator in the standard library. Alec? Oh, yeah. Yeah. So we're actually doing some WASM stuff at the moment. We're compiling Rust code into WebAssembly. Okay. And we're going to be running that WebAssembly in Cloudflare workers. Now, you don't want the regular kind of allocator for that. It's much too large. So, crates.io. There's a couple of cool actual allocators out there. WeAlloc, WASM enabled Elfin allocator. It's pretty small. This one's cool. I think there's also here, we'll toss that in chat if you want to see what this is. There's also, what is it, MeAlloc? Oh, yeah, GemAlloc, that's the one that Rust has used for a long time before they went away from it. Oh, here it is, MimAlloc. This one's actually written by Microsoft. Or drop-in replacement, drop-in global allocator wrapper around the MimAlloc allocator. General purpose, performance-oriented allocator built by Microsoft. All sorts of things. All right, so we've got our allocator here. Yes, yes it does. If we look in our lib function, we can see that we have set a global allocator. Actually, we're going to do that always. I don't see why we would only want to do that. Does that work if we do that always? Should. Let's not make this. So yeah, default allocator is 10K. This one's only 1K in size. It's slower, but it's smaller. Which is funny because as long as it works in WASM, we're good. And for another 10K for Cloudflare to shuffle around, That's not much for them. It should be fine. It's not being sent to a browser. We don't have to worry about the extra weight. So maybe we get rid of the wealloc. I mean, unless we're working up to like a 9K boundary, like how big can our WASM files be? What's this? Let's just we're gonna dump wealloc for now. Just see if the default allocator will suffice. Oh man, I love this song. There we go. Oh, I deleted too much. There we go. And if we don't need that, then we don't need CFGF. Okay, let's see if it works. Cargo check. Cargo build. Let's try it without. We'll try it with WASM. I could just tell a joke. Oh, I was muted. Yeah, 10K, 9K isn't going to break the bank here. So, I mean, look, we're at almost 3/4 of a meg. I wonder what's the largest weight here. Um, Argo, Rust, size. There was a tool for this. Pants. I think it was called like bloaty or something. Cargo bloat. I think we already have this installed. A man goes to his rabbi and says, I think my wife is trying to poison me. The rabbi says, Worry not. I'll talk to your wife. The next morning, they reconvene. The rabbi says, I talked to your wife for 3 hours. Take the poison. Oh, that's so sad. Uh, oh, it's showing me. No, I want to know crates. Oh, the text section. What? That doesn't seem right. Is this like a nightly only thing? Maybe we should strip it? I mean, how do we do that with WASM? Because we can build that. Oh, let's do release. All right, I'll worry about that later. It's interesting though. I thought it was much smaller. Oh, we're not using Routerify. Do we still need lazy static? I think so. It's over here. Yeah. So we need that there. All right. So our handle function is empty at the moment. What are we going to do in here? It was just a to-do. Want a little bit more to go on. Get the request. Going to be doing some stuff there. In order to get this to work, we need our handler. So our route needs to record its handler. Where are... Oh, here it is. Routes. Handler. It's not... Yeah, we're taking a Cloudflare event. And that's not going to be the case. We're converting this event into an HTTP event. Our request. You'll take that and you will return an HTTP response. That's always going to be the same, isn't it? I think we should be able to convert all Cloudflare workers to using the same type. Right now, we have a little bit of a disparity. And that's in here with these doubled up pieces, right? The unit here. If we could simplify this, it simplifies everything else. Because now this is going to bubble out here, etc., etc. And we don't want that. Because then somebody doing the get is going to have to think, you know what is the body type going to be for this request? Which is fair. It's a fair question to ask. wasn't there another, sorry, Asref stir? Yeah. I think this is what we want. And then we can, no, we want to be able to go into string. So that's fine. See, this here should be a readable stream. And here, this should be a readable stream reader BYOB thing. Oh, I see. Problem here, though, is that our types. No, if this router is going to be generic, we can't have these types in here. Okay, those go away. All right. That means for each one of these, we have to know what type that is. Wait, what's it saying here? Oh, it doesn't know what size that is. Fine. We can box it. That shall be a dyn function. Okay. Router, same thing here. Now, yeah, given this request to response you, yeah, they all have to be the same, don't they? When building something like this up. All right. So far, so good. Build. Mismatch types. Yes, yes, yes. Oh, the handler's wrong. It needs to be boxed. Expected result route box. Found result route requestee. Responsio. Oh. Okay. I've got these mixed up. Yeah, that takes a requestee and a responsio. Wait, no. Okay. H might not live long enough. Oh, the handler. Okay, now we own it. Type mismatch in function arguments. Expected signature of function that. Yes, this should be a HTTP request. I know that's not right. Okay. Handle takes 0 type arguments, but 2 were supplied. Okay, now we're down to this point. That, and we don't have the match working yet either. Status. Okay, that's fine. Hey, PHP. It's going to be run on Cloudflare's workers. So on Cloudflare's Edge network, or Edge servers, you can actually run WASM or JavaScript. So we're trying to set up a kind of serverless website builder using WASM, using their workers, using their durable storage and key value store. All right. Body. These are the admin, the sadmin. Oh, and this should be a. So what if we couldn't build it? All right, so let's change this to take a result. Well, what sort of error here? Hold on a second. Okay, yeah, the complexity of the problem for a serverless website builder. Um, well, part of it is I want to use Rust. So we have to compile down to WASM, which Cloudflare supports. We then also don't have types for all of their kinds, so we have to extern C some of their types here. So we have to build up kind of some of the fundamentals. Now, Cloudflare has a number of APIs. Let's see if we can find them. I know I have this open somewhere. Did I close the Cloudflare bits? Maybe. So if we go into the workers client, workers area, we're going to be using a couple things. Durable objects. Durable objects give you the ability to create transactions. Okay. So transactions plus storage. KV, they don't do transactions. So you risk clobbering writes. Or getting, timing errors, right? I wrote this and I read it. Oh, and it's still the old value, like that sort of thing. If you're on two different machines, right? Whereas durable objects doesn't do that. So we need to put things into the KV store that can be put into the KV store. It's you can store larger things into the KV store, more things. It's just bigger, faster, right? And durable objects, we need to keep those pieces, those transactions and wrappers as small as we can. Because we only get 50 milliseconds to run, but it should be enough. Yeah, and it'll be like Wix or something like that, yeah. Something simple, right? And it'll grow. So this is actually for a neighbor. I'm building a neighbor a website, but I'm kind of doing it my way. It's like, okay, I've been doing web dev for 20 years and I like Rust. I like doing back end stuff too. So I didn't want to just fire up a, WordPress forum. So we're building one. I sense a new presence among us. But we're going to be building it kind of on our terms. And thank you. How do we say that? Like Chatsbergen? Thank you for the follow. Oh, it looks like Mitch has. Yeah, we gotta fix that bug in Mitch. All right, the glitter stays on the screen too long. You can see. Oh well, thank you. It's not that good for networking. Oh, what do you mean? Yeah, lots of sticky notes. Exactly. Man, I find it great for networking. Maybe it's a specific subset of networking, but it seems to be like right in line with networking. All right. Come on back to Kitty. Oh, good. It actually got that. Okay. We're going to leave the error here. I want to actually leave this error because the response type is wrong. Um, but I want this to be a result. Let's create our own result type. And we're just going to do Boxstein here. Arguably, we don't need send in sync here because we're in WASM. So we're just going to say it's kind of a feeling that Jizubaku, you're being a little cheeky there. You're like, you know, like it really is good for networking, but you're just kind of doing it the opposite way. What is it? Not cynical. The opposite of that. Oh, words are failing me. What? Oh, facetious. Yeah, you're being facetious. Let's see. Actually, we want to map error on this. Oh, good. Now we get the type error, which is great. You try making some real-time messaging system. The problem is to transfer data between async tasks in Tokyo and PSC channels is very slow to pass messages if implementing actor system. Oh, interesting. Were you doing copies? Because I know if you're not sending the data, if you have to actually make copies, that can be very slow. Then you can also use something outside the channels, right? You could use a slab or something else that you have your data on. And if you're sending messages like that, you probably want to use something like bytes. Were you using bytes? Actually, I'd like to know more. I'd definitely like to know more. I know we're tossing out like questions and answers and stuff, but if you could describe it, I'm definitely curious. All right, we don't have the right type here. We're going to have to create some sort of type for this. Like, how do we create one of those? Let's go back into router. Router should be agnostic to all of this. The exception here. Okay, that should be a result. Yes, and this type is wrong. Oh, put that in the wrong place. There we go. And why were you using an actor system? And which one? I mean, Actix I've used before, and that's quite nice. It's using the older version though. Okay, mismatched types. Yes. Good, good, good. Okay, this is working. Yeah, here we want send and sync. Fine. Arguably, it doesn't have to be that, but I mean, I'd prefer it not. That's because this here, send and sync. One answer. Um, ooh. Thread 1 loops over a vector of TCP streams, reads the first message from the queue, and then sends it to the processing thread, which processes 500 messages in a loop, where there are two ways to send this data. One with the arc mutex, but it causes too many, queue locks, which are costly. Another is MPSC to send messages. This doesn't block the queue, but the queue is not readable until the entire queue is validated. What? Why do you have to wait until the entire queue is validated? Do you have to have 500 valid messages? I mean, you should be able to start reading out of the queue as like the MPSC channel as soon as something's ready. As soon as there's something in there, a task, whatever it is, should be able to read that immediately. Oh, but you're using actors. And can an actor wait on an MPSC channel? That I'm not sure on. That's interesting. GZBaku. Um, yeah, async on over actor model probably is overdoing it. Um, Technically, yes, but you end up doing actor frameworks in Rust using async. It's in this case. All right, what's the next error here? Which actor framework were you using, GZBaku? See, we want this to be a readable stream BYOB reader. How do we create one of those? So did you write your own actor framework? All right, let's find this. Allows reading into a developer supplied buffer, thus minimizing copies. Is that the buffer? We provide the buffer? Array buffer view? You did implement Axiom before, but it had too much overhead. Oh, interesting. Is this in crates? I think I looked at this. Highly scalable actor model. Do you still use it? I mean, it's hasn't been updated in a while. That must have been fun to make something like that. Ooh, an example. Hmm. It looks neat. Looks cool. Let's go standard, our docs, some other docs. Okay. Yeah, I've never played around with Go, so I wouldn't be able to kind of gauge the performance between the two. But man, I'm thoroughly enjoying Rust. What's an array buffer view? That returns a promise? How do we use this? Using streams. Okay. Yeah, no, I don't want to do that. I want to provide my own data. Oh, interesting. Huh. Array buffer view is just an array of uint. 816 array you can read in JS. Okay. So is that in JSys? Oh, array buffer. Wait, is this? Yeah, in JSys. I guess I'm wondering how to actually do this though. Readable stream, BYOB reader. I mean, maybe I'm doing the wrong thing. Maybe I should be providing something else out. Because a readable stream is just, we can't create them in here. We can pipe it to something else. We can get the reader. It feels like I'm using the wrong one again. Do we get something off of the request that we can reply to? Or here, let's go to where's WASM? Runtime API, WebSockets, blah blah blah. Oh, there's a playground. I love playgrounds. Okay, so WebSockets are early access. Oh, you're trying to break the 10K barrier? Yeah, the overhead doesn't sound right. You should have been able to drop those as soon as you were done with them. Well, I mean, it almost sounds like you want kind of a one-to-one actor to TCP channel, right? So you shouldn't have a lock in there to begin with. That's one of the beauties of actor systems, right? So they're supposed to be really lightweight workers, kind of like async and Rust. Okay, event to respond with. You can use transform stream to stream a response body after setting the front matter. Okay. Minimizing buffering is especially important. Okay. Now that we call response body pipe to writable, but do not await it. The runtime can continue running a function after a response is returned to the client. It's handy. Just pumps a subsequent response body to the final response body. However, you can use more complicated logic, such as adding a prefix or suffix to the body or process it somehow. Hmm. Well, then, no. Back out of there. Ooh, pricing. Oh, and here they're doing it on memory. All right, so where were we? Runtime APIs, add event listener. See, here we get into event. Oh, it's on fetch event. Respond with. And that's a response or a promise. I wonder if we could set different kinds here. Uh, so I'm getting stuck up on what do I do with this string? All right, it's got to be in a certain type. And I'm trying to use this Cloudflare type with the BYOB reader thing. Redis Spark? Yeah, have you gone through the Erlang Elixir courses or the Erlang book? There's a couple of great Erlang books, and they really helped me understand how to use actor frameworks. I would also highly recommend those. There's two of them. One written by I think Joe Armstrong. No, but it's not that one you want. There's Programming Erlang and then Erlang Programming. Two books, two words, different order. Oh, let's see. Which one is this? No, we don't want this one. We want the is it from Prog? Oh, Joe Armstrong. Is this the right one? No, it's not him. Programmer. There you go. Yeah, it's not the Joe Armstrong one. It's the other one. So this one, it's got plenty of good information in it, but the one I liked better was the other one. So Erlang Programming. So it must be this one. Oh yes, Francesco. Yes, this one. This one I liked better. I went through both of them, um, and generally with actor systems, you don't want choke points, so you don't want one actor handling things for like 50 sockets, right? You want as little contention as possible in the system. So, how you design your actors um, greatly influences performance. And if you even just have the smallest choke point, it can have disastrous effects. So you want to make sure that that's really avoided. It's like order of magnitude, in even in Erlang. It's surprising, just because the contention, right? All right, we could figure that out later, or figure it out now. I mean, maybe we use a readable stream. But we can't create readable streams. Let's see, this is getting me. And this isn't it either. So if it's not these that I can use, because those are used for transforming. Buffer source? Oh, what do you mean? Processing them becomes very difficult. So the thing is, actor systems are lightweight, but if you have 500 connections pumping data, then the very first step of receiving message, start using too much CPU, and then that becomes a choke point in itself. Actor systems aren't very good at back pressure either. So you have to figure out how to introduce back pressure. And it doesn't sound like you should need a lock for this. I mean, the way I see it, you basically, I mean, if you're using an actor system, you should be able to, yeah, have 500 actors managing the connections in each one of those actors that takes some of the data and tosses it into an MPSC queue, right? Multiple per single consumers. And then you have another actor that's just waiting for queue events. And to me, this sounds like something that you don't really need an actor framework for. I mean, I would just use tasks in Tokyo for this. I really like actor systems, but coming into Rust and doing async Rust, my first foray into async was actually using Actix, not Actix Web, but Actix, the actor framework system. And then after getting through and getting something working with that, I then took the actor framework out and just used async Rust, and it was a very nice experience. All right, so we have WebSockets. Yeah, this turns out that's invite only. You don't get WebSockets. Code body. I mean, it feels like it's maybe going to be buffer source. That it's okay. So we just return an array buffer then. I mean, I wanted to use this readable stream. Like, oh, maybe I can just keep providing data, right? But it doesn't seem like that's the case. Can you? Is there another way to respond? I mean, this is the response body. Readable stream, form data. And readable stream was the only thing that seemed like it had a future. Pipe to, pipe through. T, get reader. It's impossible to manage resources for Tokyo tasks? What do you mean? So, I don't think I've had issues with that. And this is what we would use if we were reading the body. Pair of streams. A writable stream known as its writable side, and a readable stream known as its readable side. Writes to the writable side result in data being made available for reading from the readable side. Oh. Okay. Currently only implements an identity transform stream, a type of transform stream which forwards all chunks written to its writable side to its readable side without any changes. Okay, well that's fantastic. So if we use this, we just create a new one of these, return the readable side, we give this to whatever the task is going to be, the future that needs to collect all the data, and that's it. Oh, lovely. Okay, so we need a transform stream. I think we see the way. The type transform stream. What can we do with the transform stream? Just a constructor. Okay. There's our transform. I kind of want like a different extern C for each one of these. Like one for event. One for request. Here's CF. And we have our miscellaneous ones. Let's toss another one of those up there. Response. Okay. Oh, these go in event. There we go. I like this a little better. If you have a Tokyo async spawn looping over a TCP stream reading data, how would you limit only this group of tasks to 25% CPU usage? You're missing something. Okay. So what you could do, it sounds like you're using like an unbound channel for your communication between those clients and the server. And here, so here, what I would suggest is you have like a task per connection, right? Each one of those feeds data into an MPSC bounded channel. Okay. And then you have some other task and it, one at a time starts to pull data off the channel. And because you're going to be using a bounded channel, right, that's a big thing in that you can actually, it gives you a little bit of back pressure, so you're not pulling in data faster than you can process it. And in this case, this sync could run at, 100% CPU, but these guys would have some sort of back pressure due to the bounded channel. So you're not going to be just filling up memory into some unbounded channel. Oh, what's a bounded channel? So if we go to the Tokyo docs, okay. So a bounded channel is a channel that has a fixed capacity, right? It can only store n number of messages, and you define that when you create the channel. An unbounded channel, it will grow until your system runs out of memory. Now, it sounds like, it sounds like you're being, concerned about resources, etc. So you probably want to use a bounded channel to begin with so you don't run out of memory. So bounded channel, well, you can kind of find it in here, but you have a sender and receiver as opposed to an unbounded sender and an unbounded receiver. So in this case, send is async. And this is different from the unbounded sender. And if you have an unbounded sender, sending always works. So it's not actually async. In this case, sending here, you have to wait because the channel might not have room for you yet. If we go back to unbounded senders, send here is not async because it always succeeds. You just always allocate more memory. In doing this, there's no lock. Right? You basically have a one-to-one task per connection. Give me the data, I'm tossing it in that channel. I mean, what would that look like? That would actually look something like a Tokyo spawn async. Actually, if you have incoming connections, so let's say you received in some sort of loop, you had some sort of loop, right? Let incoming equals, I don't know, TCP listener next, right? And we do that, and then we're going to spawn something for each one of these. You could spawn some sort of task, right? Well, what do you spawn inside there? You could do like incoming and then pipe that into something else. 2020, your life problem is solved. Because this has a, well, if we go into TCP stream, we should be able to forward that into a channel just directly. Because it's async read and write. Where's our stream? Oh, that's right, that's right. Well, you could split the reader and writer if you wanted, but you don't. Doesn't sound like you need to do that. Yeah, on top of this, if there's some other things. Where did stream go in Tokyo? Yeah, this is a little different. Oh, they've been moved into the Tokyo stream crate. Fine. So stream.ext is implemented for what? For the stream traits in features core. And this is implemented. Okay. How do we go into stream? Do we need to have a Where's TCP stream? There's a way to actually take a TCP stream into another stream. I think that's using the util crate, right? Because inside of here, say IO, yeah, stream reader. Okay, and then so basically there's a series of codecs. Some actually really simple, like a line-based codec or a size-based codec. Maybe receiving data that says, okay, my first 2 bytes are the size, the rest of it's a packet, right? So you can use one of these codecs to be able to pull data out of your TCP stream and forward that stream into a channel. Let's see. The one I end up using most of the time, where is it? Let's see, let's scroll to the bottom. Yeah, it's usually the length delimited codec. It's the one I end up using most of the time because I always send how long the next packet is first. But there are so many options with this. So many options. So yeah, basically take a TCP stream, wrap it in something like this, pipe the data into that other element, into the MPSC channel, receive the data on the other side, do your calculations, you're done. It's just that easy, right? No, it's not just that easy. Oh, you're welcome. Yeah, read exact works very well. It does very well. Oh, I'm glad you like the music. I sense a new presence among us. And welcome to the stream. Sir SR, is that Senior Mordred or is that Sir Mordred? Sir is fine? All right. Sir Mordred. So it looks like we need to create a new one of these. It creates an object that has a readable and a writable. So we need a getters for that. That is a writable stream and a readable stream. Okay, let's keep cleaning this up. Okay, where were we? We need to be in here. So we've got, yes. I like having these WASM bindgens per each type. That at least gives some boundary to it. Otherwise, it's like 1,000 lines of types, and it's not all that helpful. All right, a couple of these, because we're going to have a couple more. Why not? All right. I'm just going to toss some of these in here. You get your own, and you get your own, and you get your own. We're going to fill those in later. I'm just prepping for it. Almost there. All right. That's all of those. Toss in some more spaces. Get rid of those defines. Now it's a little bit more obvious. We're going to grab the little getter. Where'd it go? Here. Going to have two getters. How do you add those text and explains on doc.rs in a crate? So inside of Rust, you have doc comments. A doc comment has like the triple slashes here, or is it the slash star star? So anything is it star bang? I forget if it's like that or if it's a different way. But basically, you can document all sorts of things. And in that, Rust doc comments. So yeah, line comments, block comments, inner line doc comments. Yeah, outer line doc. So if you're on documenting something from the inside of it or from the outside of it. And where was the other one? Oh, here's the, yeah, you would use this one for the module because you're inside the module. And they'll have some examples here. But the documentation is just fantastic in Rust. Highly recommend using it. Okay, so we're looking for, we're going to fill out some of that. Oh, it was the, oops, too far. Transform stream. Yes, we're getting the properties here. We had readable and writable. Pub function readable. This is, and but what is a readable? A readable is a readable stream. But here, it's transform stream. Returns a readable stream. Yes, yes. And here, function writable. This. Gives us a writable stream. Let's make sure we have those defined. Yes, that one and that one. Good. Let's put those next to each other. They're kind of far apart. Readable and writable things should be near each other. Hey, what's up?
Stack of iron blocks in Minecraft.
I'm not granting blocks at the moment, though. All right, I will after the stream. Yeah. See, mom knows. All right. Yeah, forever. Yeah. We've got a little Minecraft server on the network. And my daughter's asking me to grant some blocks for. And clear some of those. Great. Okay, so we have our transform stream, and we've got readable and writable on that. That's good. Okay. So we should be able to create one of those now. As if we can create a writable stream and a readable stream. That means our response type for body is not going to be a BYOB buffer one. It's going to be a readable stream, which will simplify this a lot. Let hmm. Does this even work? Oh, they're getters. They're getters. Drat. Okay, so we create a new transform stream. So there's our stream. Stream dot readable. Let writable equals stream dot writable. Okay. Now in this case, we're going to return readable. Perfect. And writable, we want to write to. Hey, welcome, Brooke. How's it going? My stream thing isn't working. Have I tried implementing a vector from scratch? No, I'm beyond re-implementing like standard library stuff. I'm more into making things as opposed to kind of standard library stuff. And welcome. Thank you for the raid. It looks like they changed the notifications. Welcome, everyone. So we're doing WASM inside of Cloudflare's workers. And at the moment, we're building up a router system. So you can set up a route, say this function handles it whenever somebody comes there. And it responds to it. So let's see. What's going on here? Ah, readable stream, yes. Readable stream. What'd you work on today, Brooke? Happy Sunday. Happy Sunday. Okay. Oh, volcanic popsicle. I think he's talking about I think they're talking about a VEC, right? The Rust kind of list type, right? Playing with Rapier 2D physics library. Nice. 1,000 balls in a container and seeing what happens. Oh, that's fun. That's fun. All right, and what's this saying? Oh, this is saying that unit is wrong. It looks like it's just going to be a readable stream for all of these. Oh. Oh, readable stream BYOB reader. That's right. Where did we put that? It's in CF, Cloudflare stuff. How many of these do we have? Just those two. Just needs to be readable stream, not readable stream BYOB, blah, blah, blah. Oh, the standard Rust vector. I think we were talking about the standard Rust vector. Let me know if that's not it. But yeah, a vector like you know a geometric vector. That's straightforward. Okay, headers isn't used yet. We're gonna leave headers there. Nice little reminder. Is everything going to work now? I don't think so. Oh, we still need this to do. Handle, yes. So at this point, we have a request, and we're going to go through our routes, trying to find the first one that matches the request type, right? Is it a get, a put, etc., and the URL. So first, we match the method. All right. For handler or route in the self.routes, if route dot handler. Yeah, we need a method. Is that a function? Yeah, that's a function. So if that's the same, or rather, if it's not the same, we continue. If it is the same, how do we want to do that? And request.uri. Let's extract these into variables. Say methods there. URI's here. Oh, you're off to lunch. All right, Brooke. Have a great day. Let's see, regular expressions. Where is it? The request is encapsulated, but we need to know whether or not the request matches the route. What? What's up? No, not yet. All right. What do we want to use here? Is it match? Find? Captures find. I mean, maybe it is find. Or is a match. Okay. Sorry, I wasn't watching Automod. Oh yeah. Well, we'll go ahead and just clear that board. Um, encapsulate the request. So I want to try and keep anything in the router module kind of clean. Um, it'll be dependent on the HTTP type and the regex type. I might create. And the reject's great, but beyond that, I want to keep it really, really thin. Excuse me. Did I have that muted? I just went to go clear my throat into your ear. I'm so sorry. There we go. Sorry about that. So sorry. I think I'd clicked on Mitch on accident. It's this invisible window on my desktop. Okay. Let's see. How do we use this? Using string pattern methods with regular expression. Haystack contains that. Find. Interesting. What does split do? What if we have patterns with a split? And what if it doesn't match? Otherwise, find is faster for discovering the location of the overall match. And this is just a start and an end range. Okay, so now we want the captures if we have values, right? Because we might, if variables is empty, then we'll use one. If it's not empty, we'll use the other. So if the method's the same, we have to do something here. You know what, in this case, let's just do return route.handler. We give it the request. Unit. Wait, where's unit? Oh, in the case where nothing matched. Oh, that'll never happen. Right. No method named handler. Handler is a box function. How do we invoke that? It's a field, not a method. Dot and then parens? What do you do? Oh, there we go. We need, yeah, there should be a result. And the method is get. Okay. All right, I'm not seeing this one from readable stream. Oh, from a result. Right now it's a result, right? That's right here. Just unwrap that for a moment. Okay. Does it build? Oh, cannot move out of self.routes. Okay, we got to the next layer of the compiler. Why is it moving out of that? It's trying to copy it because... Why? We just want to execute it. Consider iterating over a slice of the vector. Oh, okay. Thank you. Much better. Okay, that builds, maybe. What is it? Wrangler. Dev. Cancel that. We should get an error here. Oh, we didn't. Why didn't we get an error? Oh, because it was a GET request, and that's all we were matching on. And then we had the writer returned. Okay. Body was null, type fetch. Good. Now, let's go back to lib and have some content. What do we do with the writable? Writable stream. Let's see, it looks like to write to a writable stream directly, you must use its writer, get writer. Okay, so we've got a property locked. That looks like it's kind of read only. We have abort. Okay, and then we also have get writer. Let's go back into CF. Writable stream. We need a getter. Let's say for locked. That's bool. Now what if we just need function. Oh, where is that? We're in Async bind gen. No, not that. Hmm. Why don't they show the macros here? Should be, oh, Async bind gen macro. There we go. In the prelude? Yeah, okay. Let's go to the other docs. Here. Okay, here we go. Okay, it's just method. And we provide the arguments and the return type. Okay. Pub function. Was it get writer? This is a writable string. And what was that returning? Writable stream default writer. All right, so it's going to be one of those, which pub type that. Okay. Then we also have abort and, oh, and we have to, JS name is equal to, is that? No, okay. No quotes on that. Oh, the function abort. This writable string returns a promise to void. Interesting. Okay. It looks like a string. Yep. That's optional. Okay, so an option string. And we get something back. I don't know. This is going to throw me. Promise to undefined. Promise, let's see, reasonable will be passed to underlying things. Abort algorithm. All right. Promise. Yeah, promise to any. Okay. Oh, that's interesting, though. Look at that. They have TypeScript types here. That's fancy. Huh.
Mom, you just got a new house.
It's all right. So we get the writable string back. We get the writer. Let's go back into lib now. Get writer.
Did you print your windows? We do. I think the bees really like your house. Yeah.
Okay, now what do we do on a writer? Closed, desired size. Okay. And you can write anything into it. A chunk of data. Wow. All right. Back to Cloudflare. Writable stream. Now we need to fill this one in. Let's see, some of these. What's our first one going to be? Our first one's probably going to be a getter. Desired size. Function. Actually, toss that in there. Next. Closed. Okay. Function that. Okay, now desired size returns an int. And closed returns a promise. Oh, does this have to be above it? That'd be silly, but possible. Oh, it's just not, the block isn't finished. Now for abort. Okay, that was already done. Close, which is another promise. This one is like abort, but without a reason. Release lock. Oh man, I love this song. Oh, and these here shouldn't be writable streams. These should be writable stream default writer. Release lock. We got that. What else? Right. Returns a promise. I don't know. I don't know about this one. Oh, the function, right? And this is like an any. What? I mean, I obviously don't believe it. Wait, should we do string here? Let's do the boilerplate bits here. Promise. Okay, it resolves if the operation succeeds. Great. Data any? No, that's standard any. String bytes. U8. What about types? Supported types. Okay. JS value, box JS value, constant. I think it needs to be like a stir. Maybe like so. I don't know. I'm not doing anything with promise yet. We're also not spawning any tasks. So let's just see if we get hello world out of that. We're not in an async block or anything, so. Huh. Build it, run it. Excuse me. Sorry. Ooh, error 101. Perfect. This transform stream is being used as a byte stream, but received a string on its writable side. If you wish to write a string, you'll probably want to explicitly UTF-8 encode it with text encoder. Oh, wow. That's neat. Could we do something like that? Okay, that ran. Or it compiled. Okay, we got data back. What did they give us? No response. Content length is nothing. Interesting. Okay, well, at least it's compiling. half the battle. Now let's go back to the previous error, because that's interesting there. I mean, maybe. I mean, that's the same thing. But what is a text encoder? API. Where's text? All right. We just give it a string for a text encoder. Okay. And we get a uint array, uint8 array back. So why can't we have it provide that already? That takes a future. Our promise is unknown. Huh. It's supposed to be a promise. Okay, so future is not implemented for promise. I see. So we convert that to a JS future. It's nothing. All right, so JS value doesn't actually implement that. Let's just say that we wrote. Good brewery. Good morning. How you doing? Well, maybe we could see if it's an error or not. Is it an okay? I don't know. Yep, not using event yet. Just trying to work out the mechanics here. We'll throw an exception. Byte stream again. Oh, that's right. We need to do transform stream. We need to get that text encoder. I don't. Why can't we just write bytes to it? Does it know that it's a string? Well, what's the error here? This transform stream is being used as a byte stream. Okay. But received a string on it on its writable side. Yeah. Can we set the transform stream property? Is there? No, we don't have. Just readable and writable. We don't get to set like, oh, this is a UTF-8 stream or anything like that. Okay, so let's build out text encoder. All right, text encoder, CF. Type text encoder. We've got a property. What's this going to be? Pub function encoding. It's a string. And then we have a method. Encode. Give it a this. Text encoder and input. This shall be. Let's see, what were we trying to do in write? What was our write function? Data stir here.
Daddy? There's even a. And it says there's no one left. They're all dead. I tried to keep them alive. I wish I could bring them back. But they're not.
Right, that returns a uint8 array. So let's say that the other thing actually takes a uint8 array. All right.
In the water.
One hiding. One survived.
But how did the rest of them die?
Okay. So in this case, let's get a text encoder. Just call this TE.
How did you not look around and see him?
Yes. Oh, did we forget the constructor for that one? I did. Okay. Again. I didn't. I thought. We're using it
TJ?
with a text encoder.
You're the one that wrote the books that said there was no one left. They're all dead.
How did it receive a string? I mean, unless we're giving it like a proper string, that. But received a string on its writable side. Okay, now. So we need to explicitly UTF-8 encode it with text encoder, which it should be. You don't have to pass the JS promise to the promise type? Oh, promise.resolve hello world? No, this write returns a promise. A JS future, rather. And we have to await that. Encode should just return bytes. I don't know if that's actually going to work. Uint8 array. What can we do with the Uint8 array? That's neat. I'm encoding a string, but you would think of it like encoding JS code. I don't follow. Here I'm encoding this text here, right? And that returns a uint8 array. And then we pass that uint8 array to something that writes, right? And so we end up with a future here, but we have to wait for this in order for it to be written. I mean, maybe I have it backwards, but I'm not seeing it. And other than, let's see, does it do debug? Oh, it does. Lovely. Oh, that failed. Oh, that was okay. I don't see a response though. Response is empty. It's an object. JS value. Sure, that's fine. Body is set to null here. Okay. So our builder received the string. That should be a readable stream. That's good. Now we have an HTTP response. Let's go back into CF. Readable stream. Body is set to true, yes. Okay, fine. You don't need that. Guess we could set the header, but maybe it's because we don't have any like content encoding. I was expecting just something to show up. Content length is 0. Try ignoring the field. No. See, I don't even think we're using this one anymore. Yeah. Same with this one. That goes away. What are we missing? So they're not being very helpful. Ta-da! Stuff. We even get our uint8 array written out. That's neat. All right. So we're not seeing this here. This just doesn't get called. And just to be clear, stream.writable is declared as an instance of a feature? Oh, good question. Let's double check that. Streams. Writable stream. Wait, no, this was a transform stream. And writable here is just a writable stream. Now, a writable stream, we can call getWriter on that, and that returns
I sense a new presence among us.
Writable stream default writer. So then we have this. So we're getting the writer. Oh, we never call close. I guess maybe we should have called close. But look at this. They're not. Oh, they do a little catch at the end where they do nothing. But other than that, they're not really doing much. Okay, then we have a writer.close at the end of that. So maybe we have to have the close. This method returns a promise fulfilled with undefined if the writer successfully closes. Okay. But what about write? Write also returns a promise. All right, let's swap this out with a close.
It's a ritual key. Key.
Come on, writer. Where's my fingers? Right. It looks like a promise, but then maybe it's a trait that duck types into a promise in Rust. Are you talking about line 20 here? Or stream.writable? It's not, this doesn't, I mean, it's not a future in this case, or a promise. Okay, now let's try closing this. The only big change here is we closed it. Okay, no text, no body. Oh, we got the AOU. So it finished that time. Actually, it closed. You're trying to understand this type of stream.writable. Stream.writable here. So it's a transform stream, right? That's what stream is. Stream is a transform stream. And writable is the right half of it, which is here. It's a writable stream. Now notice that we never got to this part here. We didn't get to the wrote it piece. The rest of it never finishes. And if we do not close it, well, we should still get to that point because we're just spawning a task, right? Yeah, we still get to that point for either one of those. So for the write or for the close, but we don't get past that. We don't see this promise resolve. So that's a JS future, which is a promise. What if we did JS future from that? That's the same thing. That's what we were calling before. Impl from promise for JS future. Wow.
Stop it.
They're using wakers. Finish state. They resolve and reject. Okay. It seems like somehow our request is not getting translated correctly. So like when it goes back out, it's not the right kind. So maybe we'll go into worker.js, get our response. Let's just do one of these. Oh, come on. Close it after the promise.await. But the problem is that the promise.await is never resolving. It never completes. And I don't know why. I mean, once that actually resolves, we could close at that point. Or we could include multiple things and then close it, or I'd just like to figure out why it's not actually resolving that promise. And I think it has to do with some misconfiguration of the response object. So we're going to dump that out. Okay, where's our response object? Response, null. URL, empty. Redirected, false. Okay, true. Header is nothing. Status, body used, false. And body is null. See? So body used should be true. The response, this is the request. Oh, let's fix this while we're at it. JS name, body used. Okay. Here, where we set the body used, maybe this is failing. What if we give it some? Does that error out? What if we get one of these wrong? I mean, I hope it blows up. That would make the most sense. Ah, it does not blow up. Fantastic. Okay. How do we know if that's actually being set? By setting it, then trying to get it again, right? And we are checking it here in the output. When you close the stream, the reference gets deleted. Which reference? Because it said in the documentation, it's good to check these things. We have a writable stream. Okay. Ends up with a default writer. And we can writes a chunk of data to the writer and returns a promise that resolves if the operation succeeds. Okay, that's supposed to resolve if it succeeds. And then close attempts to close the writer. Remaining writes finish processing before the writer is closed. So any writes that we did before should happen beforehand, before this.
Pizza. Pizza.
Let's look up JS name again. Not there. I mean, maybe it's just a getter in this case. Oh, interesting. You can also use JSName to define multiple signatures for polymorphic JavaScript functions. Look at that. That's fancy. Okay. Gotcha. However, we don't seem to have an issue with that at the moment. But our body is not being set. Oh. It's a setter. Seems all right. All right, and if we didn't do that, we've got writer. Just some data, right? It doesn't complain about this. Uint array. That's right, we changed the type. What does uint array have? Can we do from something else? Okay, yeah, we could do from a slice. Oh. Okay. That returns a promise. Yes, we know. Okay. Still no content length.
Oh, it's gonna use the diamond sword.
Body is null. Body used is false. And where are we doing that conversion? NCF, down here at the bottom. From our HTTP response of a readable stream, we set the body here. Do we have to do this one first? I mean, that would be silly. Be like, yes, we use the body. That seems weird. And what if we set the status to something else? Let's set the status to like 204. Right, just to see. I just want to see that it changes. Okay, that's running. What do we got? 200. Huh. That's not right. Yeah, still not right. Oh. I'm looking at the wrong one. Okay. Am I? No. This is it. This is it right here. Create new response. And this is, yep, this is the JavaScript response. Set status. Console log. Yeah. How do we invoke JavaScript's console log? If we go to, let's go to CF, or hold on a sec. Okay. So logging. All right. JS namespace on console log stir. So we do something like this. Huh, interesting. And let's switch this up. Let's say that this is oh goodness, what are we trying to log out? A response. Oh, down here, right? Use of undeclared creator module console. So how do we use that in Rust then? I mean, dot? No, that's not going to work. It's supposed to be a namespace. Colon should work. Log many, okay. Console underscore log. Oh, web says console? Well, what is this? The web sysgrid already has it defined for us. Oh, well, fancy that. All right, but if we just did log, is it going to be happy with that? Missing unsafe. What? What does it mean? It's unsafe. Its operation is unsafe and requires an unsafe function or block. I don't believe you. Ah, okay. We should borrow there. Yes. I'm gonna call it debug. Okay. Good. Oh, look at that. Wait, why? I mean, this. That doesn't look like we're trying to log out. I mean, R should be HTTP response. This response is not an event. I guess it does have the cloud. Okay. URL redirected. Okay. And more. Oh, give me some more of that. I want to know what those more pieces are. Dot body. Yeah, that's going to be a stream, so that's not going to work. Interesting. How else can we debug WASM stuff? Also log body. Now, it should tell me I know nothing about this. Yeah. We could just return this to JavaScript. And that's exactly what we're doing, isn't it? Yeah, we call from. That's the function we were just in. Well, for response. Handle request. Unwrap. Yeah, we pass that back to JavaScript, and JavaScript logs it out for us. Right here. All right, let's ask the Oracle. Cloudflare worker. It's empty. I'm suspicious of, let's see. What did we have before? GDF. Before. Yeah, we're doing like into Rust event and a bunch of stuff. Here, this is what we had before. Let's put that back in there. Let's set the headers on the response. So headers is going to be this. Headers. Something like so. Is it just because we didn't set up the headers? Please, please be the case that we just didn't set up the headers. Pretty please. Because that would make so much sense. Okay. Like our response headers, we didn't even get that information. Look at this. Nothing. Report to cookie, yada yada. Headers are empty. All right. Then if we set the headers, is it still going to be empty? See, it's still type is plain. Yeah, headers are still empty. Interesting. How do we set the headers on the response? Response, headers, properties, headers, methods, redirect, JSON text. Did I spell headers wrong? Oh, we are in JavaScript. Response.headers equals this. And then we log it out and it's not there. I'm a little suspect, you know.
Which one is that?
Maybe we can only set the headers once. Or we should only be able to set the headers before we actually send it out. But we didn't send it out yet. Like there's the response. And this is strange. Really strange. I mean, it's not telling us it's frozen or anything like that. We're able to modify it somewhat. I mean, the URL is empty. Maybe that's an issue? Status, oh, at least we're getting the 200. I'm not actually setting up the 200, am I? Consider writing the name of the subscriber over my body in every response. Yeah. No idea. Oh, I didn't see the bad joke. I follow. Okay. So we're still getting plain text. It's like the first instance is slow. After that, it's fast. So what do we see? Okay is true. Headers are empty. Status text is okay. Status is 200, but okay, maybe we should do this different. It could be that part of these things are read-only. What if the response, we have body and init. Init is optional. It's an object that contains custom settings to apply to the response. Valid options for the options object include status, status text, and headers. Okay. That shouldn't affect body though, because body is supposed to go in there. I know. Maybe we should create that correctly, because right now we set body later, right? It's a readable stream. Maybe it's not maybe it's not writable. We can't write, maybe it's not a setter, is what I'm trying to say. So let's set up the constructor here. And I think we'll just pass in body because init is optional. Because I don't know that I guess I could create one of these objects, just pass it in there. Kind of like a response options. Okay, where's response? There you are. New body. It's going to be a readable stream. Response options. Type. No. Let's try it without. Okay, and we're going to comment out the body bits there. Okay.
Pass body in. Comment these out. Oh, what is this? There's text. There's text. Wrote it is true. Oh, so we have to pass the body into the constructor of that. Okay. All right. The script will never generate a response. Wait, what is that what is that pertaining to? Error. The script will never generate a response. Uncaught in response. Live. Okay, so we did that there. Wrote it was true. Okay, let's go back to where we were. Text encoder. We should get a hello world. Oh, great. And we've got hello world. And, oh, interesting. No funky error. Okay, headers are still empty. All right. Gonna leave that there for now. Result, yeah. Underscore. Okay, cool. 204 wasn't there, was it? Ah, yes. So we need to use the init for that as well. CF. We need a type for this, don't we? It says we need some sort of object that matches this form. Right, it needs to have init, status, and headers. Well, sorry, status, text, and headers. It's either that or we define just some sort of object. See, can we do that? Or we could JSON encode something. Yeah. We've been avoiding that, and it's worked out really well so far. I'm glad we didn't go down that road. I sense a new presence among us. Crazy Phantom, thank you for the follow. How do we construct this? It's an object, has a couple of elements. What do we do? Supported types. Okay. Rust exports. Foo. Constructor. JS name. Okay, what about those properties, those read-only properties? Read-only. Okay. Let's create a structure for this. Yeah, what is this going to be? This is going to be response options. We will have status. What else? Status in this case was a status code. We want that as this. Probably U32 in this case, yes. Status text and headers. If there is a status text, that's going to be optional. So one of those. And then headers. Let's say that's also optional. Or just not provided at the moment. So we get rid of set status, get rid of this. U32, status text, string. Okay, these are both public. Now, what about the read-only bits on that? Yeah, because that's not copy. We do that, we need a lifetime. We might, we can't do lifetimes in WASM ByteGen, can we? Huh. Okay, what do we get from canonical? Canonical reason. Okay, it's an option to a static str. That's fine, we can do that. Oops. Okay, now we have response options. And we're not passing headers through. Let's see if we can get the code to be correct. The response code, specifically the response code. So we want to see the 204. Oh, we got an error. The response with no body status. Cannot have a body. Oh, goody. Oh, fantastic. Okay. So let's say 201. Wow, they got some checks on there, huh? Okay, there we go. Do that again. 201 created. Oh, fantastic. Body used, false, body locked. Just not seeing it. We obviously include a response, hence the hello world up in the corner. Response here. Okay, headers. Okay, fine. Status created. 201. Body used. False. What does that mean? Okay. $200. Status 200. There we go. Well, that worked. We should probably get the headers working. I wonder how we create a header object like this. How do we create an object from a hash map? Right. So in here we have headers. Headers takes us to headers object, constructor, append. So we could get a bunch of them, add them to a new one, because this looks like it's going to be a JavaScript object. So we should be able to add them, delete them. Okay. So in this case, we have to convert HTTP headers to web headers. They have header, response headers, plural. Okay, it's a header map. So we need to convert a header map into headers. All right, I'm going to save that for next time. Yeah, that's for next time. I got to get running. I'm way over. What are we going to raid today? Hash table in Rust? Oh, we will raid you. All right, we'll get that going, and then we'll raid to sorting. So thanks for hanging out today. I'm glad we got so far. That's going to be a big help. It's going to really accelerate this. It's really good. Really, really good. So, till next time, y'all. Bye-bye.